What is the speed of a beam of neutrons if their average lifetime is measured to be 2,509.5 seconds? At rest, their lifetime is 885.7 seconds. I want to go over this problem because there's a fair amount of algebra in it, and I just want you guys to see at least one example where we actually go through the algebra and, basically see how to solve it. So here is the formula we need. This is time dilation. So delta t equals gamma delta t naught. Okay. And ultimately that means we often write it as gamma, but we really should be writing it like square root of 1 minus v squared over c squared. Okay, so I know my delta t. So delta t is the 2,509.5. And delta t naught is 885.7. Now, how do I know that? Well, there's a couple ways. First, I know that delta t is greater than or equal to delta t naught. So they couldn't possibly be swapped. There's no way that could be. But I know that this is delta t naught because in the particle's own frame, it will be born and it will die at the same location. Specifically, it will be born at the origin and it will die at the origin because it is the center of its own frame. It lives at the origin of its own frame. So that's how I know that 885.7 is the proper time for the lifetime of these neutrons. Okay, so continuing, this is 1 minus v squared over c squared. Okay, so I can move the square root over. 1 minus v squared over c squared. 885.7 divided by 2,509.5. And now, obviously, I can plug this value. I'll just go ahead and, I'll do that in a little bit. Let's go ahead and square both sides. So this is 1 minus v squared over c squared. This is this whole 885.7, 2,509.5, and this is all squared. Okay. I need to solve. Remember what we're solving for. We're solving for v here. So I'm going to move this to the other side and consequently move this to the other side. And so taking that up over here to the right, that's going to be 1 minus 885.7 over 2,509.5. Obviously, you could go ahead and calculate that fraction. I'm just trying to move things along here. All right, and now we're solving for v, so we can take the square root of both sides. Square root of 1 minus 885.7 over 2,509.5. This is squared. And this equals v over c. And so now I'll go ahead and plug that all into my calculator. And I get 0.9356 approximately when I take this square root. This is what I get from the square root. I'm solving for v, so I'll move the c to the other side. So this is all times c. And that's the answer. And if you're doing the length contraction formula, now of course that formula is gamma L equals L naught, okay? I mean, yeah, we're dealing with lengths, but this formula mathematically is the same as this one. So it's the same approach when you're doing length contraction.